In this topic we'll discuss about a term here, moment of a force. Okay. uh, Consider a body. Here one body is there, it is irregular shape, which is pivoted at point O. Okay, it is pivoted at point O here. This body is irregular shape, body is pivoted at point O. Okay. Now next one is next step is, if a force F, the force F is applied horizontally, one of the force F, it is applied horizontally on the body with its line of action. The line of action of this force is the Fp. Okay, Fp. Here the F is applied and its line of action, if you see here, it is Fp as shown in figure here. Okay, the irregular body is there and it is pivoted at point O. A force F is acted horizontally and its line of action of force is Fp as shown in figure here. Okay, because of this pivoted point, the force is unable to produce linear motion. If you apply a force in this direction, it is unable to produce a linear motion because of this pivoted point here. Okay, produce linear motion of a body in its direction, because the body is not free to move here. The body is not free to move because it is hinged at a point, it is pivoted at point O here. Okay, instead of that, what it will do, because you are applying a the force F here, instead of that it will try to rotate, the body about point O. Okay, about point O, the body about the vertical axis passing through the point O in the direction shown by the arrow mark. Here this force try to produce a rotational motion about point O in the anti-clockwise direction. Okay, this is how the effect of this force on this body with pivoted point O here. Okay, OP is perpendicular to the line of action of the FP. Now this is called turning effect, because it will try to rotate the body in anti-clockwise direction. It is called the turning effect of the body here. Now if you come to the second slide here, what are the factors affecting this turning effect here? Because the body tries to rotate about point O, what are the factors? The main, it will depends here. The first point is the magnitude of the force here. Whatever the magnitude of the force it is applying, it is one of the main factor. The second one is the distance of line of action of the force from the axis of rotation. Where is the axis of rotation here? This is the axis of rotation and its distance is OP. This is also affecting the turning effect. Next one, if you see here, the last important point, the turning effect, the rotational effect of this body on the body about an axis, about the pivoted point O, is due to the moment of force or torque applied on the body. It means whatever the turning effect is due to the moment of force. We will discuss what is moment of force, or one more name is torque here. Okay. Now we'll go that the moment of force here. Okay, the moment of force is equal to the product of, it is the product of the magnitude of force, and perpendicular distance of here. You know that magnitude of force, for example, the moment of force I will be denoted by m here. Okay, this is m equal to the product of, it is product of magnitude of force. How much is the magnitude of force here? This is F. Here F multiply by the perpendicular distance of line of action of the force from the axis of rotation. This is perpendicular distance. This is the line of action of the force. With the pivoted point. So this distance, you have to take it this distance here. Okay, it is a perpendicular distance from the line of action of force about a axis of the rotation here. That is, it is perpendicular distance, and normally it is called as OP here. Now you can denote here OP. This is the definition of the moment of a force. Okay, if you see the next step here, force multiply by perpendicular distance of force from the point O. from the point O, that is OP. This is OP. This is very important here. Okay. Okay, now unit. If you go to the unit of the moment of force, already we know that the moment of force is m equal to force multiplied by OP. OP is the distance. Normally it is OP, that is perpendicular distance, right? How will denote here? You have three systems. One is SI system, next one is CGS system here. Normally these two are very important here. If you go to the SI, in the SI system, what is the unit of force here? It is Newton. Okay, Newton. So perpendicular multiply by the distance. The SI unit of distance is meter. Okay, this is the unit of the moment of force in SI system. Okay, if you go to the CGS system here, okay, what is the unit of force in CGS system here? It is dyne. Normally it is dyne. Dyne multiply by, it is centimeter. Normally because it is centimeter, grams and second, right? So that's why it will come here centimeter, and the force is dyne. This is in CGS system. Okay, but sometimes the force is considered in the gravitational unit. At that time, the SI, if you take the gravitational G, at that time in SI system, your the unit is force is, that is kgf. It is kgf. Okay, multiply by meter as usual, right? Here meter is there, SI, and here also meter in SI here. Okay, how about in CGS system here? In gravitational, if you consider the gravitational measurement, at that time it will comes here, that is gravitational force gf multiply by centimeter. Okay, this and this is one category, and the here Newton meter and kgf meter is one category here. This is how the notation of the unit of the moment of force. Normally in the we are considering the SI system, that is Newton meter. Now the direction of moment, this m, we have to notate the we'll give the direction. In which direction? We have two directions. Okay, one is the anti-clockwise direction, one is clockwise direction. If you see the first figure here, the figure A, the first picture, here the force is acting here in the right side direction, right? This is F. So it will tend to rotate the body in the anti-clockwise direction, like this. This is anti-clockwise direction. You see here, this is the force of action, and it will tend to rotate the body disc in the anti-clockwise direction. At that time, you have to take moment, this one as positive. This will be positive, you have to take here. Okay, so the next automatically the clockwise. If you see the second figure, here is the negative. If you see the second picture here, how is the force? It will acting in the top side. If you see here, this will be like this, and this will tend to rotate the body in clockwise direction, like this. The disc. At that time, you have to consider the moment as negative here. This is negative moment. Okay, if body rotates in clockwise, it is negative moment, and its the notation is negative. If body tend to rotate in anti-clockwise direction, it is anti-clockwise moment, and the notation is the direction is positive. Okay, okay. Now we will go one example here. A body is pivoted at particular point. A force of 10 Newton. The 10 Newton force is applied at a distance of 30 centimeter from pivot. Okay, we will consider one pivot point here, that is O. Okay, next, a force of 10 Newton is applied at a distance of 30 centimeter from pivot point to the line of action of your force. This is your line of action of your force. This is force. This will be equal to he is given here, that is the 10 Newton. Okay, here this is perpendicular distance, and this will be 90 degree. This is your pivot point. This is your pivot. Okay, what he is saying, calculate the moment of a force about pivot, about pivot here. Okay, so we know that the formula is moment of a force equal to the force multiplied by perpendicular distance about point O, about pivot point O. That is the O here. If I take that, this one be O A, this OA. That is perpendicular distance is OA. This will be OA here. Okay. So now substitute here the force. How much is given here? 10 Newton. Okay, 10 Newton multiply by OA is how much? The distance about applied a distance of is given 30 centimeter. That is 30 centimeter. Now this, because we are going to SI unit, the 30 centimeter you have to convert into meter here. We need the unit is Newton meter, right? This is 30 Newton multiply by 0.3 meter. Okay, so if you calculate this one here, the 3, it will comes 3 Newton meter. Okay, this is the moment of force in SI unit. Okay, because normally we will consider in SI unit here. Okay, now we'll go the one more example here. The moment of a force 5 Newton, force of 5 Newton. The force is given 5 Newton. About point P is 2 Newton meter. Here one pivoted point P is given, and its force of action here, the force the is given is the F equal to 5 Newton is given. 5 Newton. Its moment is given here, M equal to 2 Newton meter, and force is given 5 Newton. Okay, calculate the distance of point of application of force. Where is the point of application of force? This is the point of application of force from the P, from the point P. It means you have to calculate this distance. This distance is how much? Okay, this is, I'll take this one as O here. Okay, apply the general formula for moment here, that is M equal to force multiplied by perpendicular distance. Perpendicular distance is PO, that is PO. Now moment is given, write the 2 Newton meter. This is 2 Newton meter equal to how much is the force here? That is 5 Newton. That is 5 Newton into PO, into PO. Okay, now we need the PO, that is PO here. Therefore 2 Newton meter divided by 5 Newton equal to PO. Okay, so this Newton cancels here. The if you calculate 2 by 5, it will be 0.4 meter equal to PO. Okay, this is the distance from point of application of force to the pivoted point here. Okay,